30, 60, 90 triangles. What's so special about it? Well, we're going to look at it today. If you're watching this, you're either at home, haven't seen it, or you just need some extra practice to go through and watch this. I'm going to try and get through this as quick as I can. Again, you're probably going to need to pause at some point in time. So here's our second of two special triangles that we're going to talk about. After this, after break, we'll get into just all different kinds of triangles, nothing special. How do we deal with those? But here's one that is special. It is called a 30, 60, 90 triangle. And how do we get that? It says label the side lengths of the equilateral triangle as 2. So all sides are 2, equilateral, all sides being the same. Cut the triangle in half by adding an angle bisector from the top to the middle of the opposite side. So from the top to the opposite of the middle side. Now you have created two congruent triangles, and what is the measure of each angle? And explain how you know. Well, if we look at the original triangle is a triangle. The sum of all three of those angles have to be 180 degrees. But since it's equilateral, it's also equiangular, meaning all angles have to be the same. So 180 divided by 3 leaves you with 60 degrees. So that means these angles here are 60 and 60. This angle up here would be 60, but it's being bisected, so one angle is 30 degrees, the other angle is 30 degrees. So sketch one of the triangles and label the two side lengths that you know. Moving on to number 3. See how easy 1 and 2 was? And label what you know. All right. So we want to find the third side. So here's the triangle that I know. My side length is 2. This entire side length here is 2 as well. If this angle here is a bisector, right here, one of them is 30. Notice I'm only working on half of it because I'm only worried about half. That's what it's saying. Find the third side. It wants me to find the altitude of this. The short leg opposite 30. What is the short leg opposite of 30? Well, if this is an angle bisector, it's also a segment bisector. So that means that this segment right here across from 30 is going to be half of 2, which is 1. And we call that the short leg. My short leg, and you might want to label that over here, short leg. My short leg is half the hypotenuse. That will always be the case in the 30, 60, 90. The long leg opposite of 60, which is right here, and I'm going to go ahead and label that, the long leg, I don't know what it is. The hypotenuse opposite the 90, I know that that is 2. All right, so I know 2 of the 3 sides. How do I find this third side? Well, just like the other day when we did Pythag, we had our 45, 45, 90, and we used Pythag. We're going to do the same thing here. But think about what I know. You got to make sure you set this up correctly. I know a leg, granted it's a short leg, and a hypotenuse. So if I'm going to use a squared plus b squared equals c squared, 2 squared equals 1 squared plus b squared, or the long leg. That's what I'm after. That's what I do not know. Make sure you get this set up correctly, because if you don't, you're going to be wrong. 2 squared is 4. 1 squared is 1 plus b squared. How do I get b by itself? You should say I subtract 1. So b squared is equal to 3. And I go ahead and I take the square root of both sides. And therefore, b is equivalent to the square root of 3. Well, think about it. Is that sensible? Well, one leg is a whole unit. The hypotenuse is 2. This long leg has to be somewhere in between the whole number 1 and the whole number 2. Radical 3, if we look at the square root of 1, square root of 2, square root of 3, square root of 4, square root of 4 is 2, square root of 1 is 1. Radical 3 is somewhere in between there. And to be precise, I think it's about 1.7. I can't remember, but it's somewhere in there, which is a reasonable value. It's less than 2, but more than 1. All right, so repeat the process starting with an equilateral triangle whose side lengths are 4. Four units each. So we're going to come down here, we're going to repeat the process. 4 units. Don't worry about the other half. Okay? 4 units. 60, 30. Right? What are the measures of each of the 2 triangles? Well, we already know that that's going to be 60 and 30. Sketch one of the triangles you just created and the 2 side lengths that you know, and then find the third. Okay? Well, we just sketched it, right? So the short leg, remember how we determined what the short leg was? Go back and look and see if you need to. The short leg is half the hypotenuse, so the short leg is 2. That's what we had discussed, right? The long leg is what I want to find. That's the mystery. The hypotenuse is 4. How did we find the long leg? Well, we did Pythag. We took the hypotenuse, squared it, and set that equal to the long leg squared plus the short leg squared. All right, so I made it LL instead of, well, that's what you're trying to find, right? You could have made it B squared. So 16 is equal to the long leg squared plus 4 squared, right? And these can be flip-flopped because it doesn't matter. Let's not use 4 squared. We know 4 squared is, 2 squared is 4. It's not 4 squared, it's 4. Minus 4, minus 4. The long leg squared is equal to 12. Got to take the square root of both sides. So the long leg is equal to the square root of 12. And just like our other triangle, we simplify the radical. So how do you simplify 12? 4 times 3. 4 is a perfect square. You take out a 2. 2 squared of 3. There's your long leg. 2 squared of 3. So now you repeat the process in 7. All right? Timeout. I'm gonna call it timeout. Draw the second triangle for number 9. Did you draw the triangle? Hopefully you did. Let me guess, they gave you this to you this morning. Yeah. So sketch one of the triangles and label its side lengths. Then find the third side. Sorry about that. So sketch one of the triangles you just created, and we want our measures to be 6 units. So you should have this done. All right, so we're going to sketch one. I did mine a little bit backwards. So 6 units. That means the short leg should be 3. And again, make sure you get your angle measures in there. And how are we going to figure this out? Well, the short leg is 3, hypotenuse is 6, and yes, again, we're going to repeat the process. So 6 squared. Now, I'm going to do this backwards just because. It doesn't really matter. 6 squared can be over here. My long leg squared, or let's just use B squared instead, because that's one less letter I have to write. B squared, right, is equal to, plus A squared equals, no, sorry, backing up. Got interrupted there. That really kind of threw me off there. 3 squared. B squared plus 9 equals 36, right? 3 squared is 9, 6 squared is 36. Subtract 9. B squared is equal to, what is 9 minus 36? 36, 9, come on, subtract. 2, 16, 9 and 5 is 16, so 25. B squared, that doesn't seem right. 7, should be 7, 27, not 25. That makes more sense, because I know what this has to be, and it's not a whole number. Now, take the square root of 27, okay? Simplify the radical. 9 times 3. 9 is a perfect square. 3 square root of 3. 3 square root of 3 is the long leg. All right? Now, what are you noticing? Okay? Go back and it's investigating. So by the time we get to this one, we should know. It says repeat the process with an equilateral triangle whose side lengths are 5. So what you should notice when we create this triangle, 60, 30, we know that the hypotenuse is 5. What is this short leg going to be? The short leg should be half of that, which is 2.5. And what should this answer have in it? Regardless of whatever the coefficient is, this answer should have a radical 3 in it. Now this one's a little bit difficult because it has, well, actually this should be 2.5 rad 3. Why? Because it should be the value of the short leg times the square root of 3. Go back and look. I'm going to flip back up here real quick. Okay? Notice what our answer was. Our answer was 1 radical 3. Well, our short leg was 1. The coefficient of radical 3 is 1. We went ahead and we went to 2. Short leg is 2. Our long leg was 2 rad 3. Here, our short leg was 3. Our long leg was 3 rad 3. So here, I'm predicting, I know my hypotenuse, my short leg is half of that, 2.5. I'm predicting my answer is 2.5. So, repeat the process and see what you get. All right? So it wants me to sketch one of these triangles. Well, I have it right here. I already did the sketch. This is a little bit off for me, but we'll make do. What are the measurements of each of the two triangles? Well, again, they are 30, 60, 90. That's what they are. You can put a dash in there. You don't have to put a comma. All right? Now sketch one of the triangles. We already did it. All right? See above. You can do that. See above. So now what do we get? The short leg is 2.5. The long leg is what I'm after, and the hypotenuse is 5. Now this gets a little bit tricky because we have a decimal, but it's still the same thing. You're still going to take the short leg, 2.5, and square it, plus b squared equals 5 squared. Now, 2.5 times 2.5, and I'm going to not cheat. I'm going to look at my notes, which is what I've done before, which is 6.25 plus b squared equals 25. And at this point, you subtract 6.25, so minus 6.25, and you go ahead and get b squared equals, and 25 minus 6.25 should be 18.75. Now the only way you're going to figure this out is if you have a calculator, because I guarantee you I had to do that too. Take the square root of both sides, and I ran out of room here. So since I ran out of room, b equals the square root of 18.75. When you put that in your calculator, and I told you you needed one, you've needed one, you get b is approximately 4.3. But what happened to the radical 3? Well, would 2.5 radical 3, do you really know what that is as a value? I mean, I know what 5 is as a value, and I know what 2.5 is as a value. I know that this should be less than 5, right? So is 4.3 a reasonable value? Yes, 4.3 is between 2.5 and less than 5, right? So that's a reasonable value. That's acceptable. If you take a calculator, if you don't believe me, multiply 2.5 times the square root of 3, and I bet you get 4.3 something, 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 something. Okay? So yes, we can have answers that are decimals. All right? I mean, how are you going to factor this and find a perfect square within it and take the square root of that to get radical 3? Right? So let's look at how the diagram shows the relationship between. Right? The short leg is equal to the hypotenuse divided by 1/2. The short leg is also equal to the long leg divided by 1 over the square root of 3. Now, there's another way you can think of these as well. I think of these a little bit differently, and here's a couple of different options you have as formulas. The hypotenuse is equal to the short leg times 2, because if we take x and multiply it, double it, we get 2x. Or the long leg is equal to the short leg times the square root of 3. We will manipulate these formulas, all right? And down here in 14, I'm going to use the ones over here on the left, all right? So knowing the relationships between the angles, and again, I have my formulas down here. The short leg is equal to the hypotenuse divided by 1/2, and the short leg is equivalent to the long leg divided by 1 over the square root of 3. So now I have my two formulas, and I'm going to go ahead and input that information into each one of these. So the short leg, what do I know over here? Oh, I know x square root of 3, and I know 2x. Those are my ratios, right? Well, I know the short leg. The short leg is 2. So I'm going to put the short leg, 2 in for short leg. That's equal to, I want to know the hypotenuse, which they label as u, divided by 1/2. How do I, and I like this because it gets me to understand how to work with a fraction. This is divide by 1/2. How do I get rid of the half and move the half over to the other side? You multiply by the reciprocal, something you guys like just forget about. It's like, oh yeah, I know, and then you forget. Like, how do you forget that? Right? U is equal to 4. Isn't that the relationship? Okay, we double the short leg and get the hypotenuse, so that makes sense. Now, go with the next formula. What do I know? Oh, I know the short leg. 2 is equal to the long leg divided by 1 over the square root of 3. Now, just like here, we multiply by the inverse. Over 1, that cancels out. I multiply by 3 over 1. We're at 3 over 1. The long leg is equal to 2 times the square root of 3, which, by the way, I should have put V in for the long leg, all right? But that is what we stated in all of our notes. So there's your notes for this. I know they're kind of lengthy, but we wanted to make sure we got everything in. Sorry for the interruption.